This video is on parent function transformations. So a translation, it moves a figure up and down, left or right. So if you have a value added on to your parent function, the graph's moved up, subtracted, it's moved down. If before you evaluate, you have a value subtracted from x, the graph is moved right. Added on to x, the graph is moved left. So this is for any of the parent functions. If it's square root, cube root, quadratic, cubic, absolute value, this will work with them. Reflection, it's just a flip of the figure. So it can be flipped over the x or y axis. Okay, so if you multiply your parent function by a negative, it'll reflect over the x-axis, so flip it down. If before you evaluate, you're multiplying x times the negative, so it's inside, then the graph is reflected over the y-axis, so it's flipped this direction. Dilation. So a dilation, think of like getting your eyes dilated. They get larger. So a dilation of a graph, it enlarges or shrinks a figure. So if you multiply your function by some number, the graph is dilated vertically. And if that number is greater than 1, it'll stretch the graph. If it's less than 1 but greater than 0, it'll compress the graph, again vertically. Stretch or compress vertically. If, however, you multiply x by some number before you evaluate the parent function, so it's inside the parentheses, the graph is dilated horizontally, so side to side. So if your value that you're multiplying by is greater than 1, it'll compress it horizontally. If the value is greater than 0 but less than 1, it'll stretch it horizontally. Okay, so we're going to use all of those transformations to identify when we look at equations, graphs, and descriptions. We're going to identify different characteristics. So starting with the graph, we're going to first identify equations that will go with them. All right, so we can see right away this one's quadratic because it's the parabola shape. The parent function is always with the u facing up. So we know that this has been multiplied by a negative because it has been reflected and flipped down. Okay, we also know that the vertex usually starts at 0, 0. So it has been moved left, 1, 2, and up, 1, 2, 3, 4. So I'm just going to start with the function. So f of x is equal to, I know that it's been flipped, so I know it's multiplied by a negative on the outside of x. Remember going left and right, that's the value that's either added or subtracted on inside. Because it's 1, 2 left, that means it's plus 2 inside. Remember I said it's a quadratic, so it's squared. And then it's also shifted 4 up, so plus 4 on the outside. You can always double check this by plugging in points. So I'm going to say when x is 0, I should get out the y value of 0 because that's this point. I'm going to plug in 0. 0 plus 2 is 2. 2 squared is 4. Makes it negative 4. Negative 4 plus 4 equals 0. Well, that worked. I'm going to plug in where the vertex is. So the x value is negative 2. Negative 2 plus 2 is 0. 0 squared is 0. 0 times a negative is 0. And 0 plus 4 equals 4. Well, 4 is the y-coordinate, so that one did work. Because sometimes it's kind of hard to see, do I multiply by some number? And if you plug in some of the points, you can easily identify if you need to do that or not. All right, so looking at this graph, I can tell right away it's a square root graph. To me, it looks a little stretched out. Okay, and I also know that the parent function starts at 0, 0. So it's been moved down. It hasn't been reflected at all. So I'm going to start it out as f of x equals square root of x. It moved down 2. So that would be minus 2 outside. All right, so if I plug in where x is 0, I should get negative 2 out for y, because that's that coordinate pair. So square root of 0 is 0. 0 minus 2 is negative 2. Now I'm going to plug in when x is 1. I should get out where y is 0. Plug in 1. Square root of 1 is 1. 1 minus 2, well, that's negative 1. So I think I was right. It does look a little stretched out. Okay. If I multiply by some number, and I'm going to say multiply by 2 because, well, I'm plugging in 1 under x. So if I multiply this times 2, you can do it by using one of your values and seeing what you need to get out. I need to get 0 out of my answer, and I know I'm plugging in 1 because that's the coordinate pair, 1 comma 0. Square root of 1 is 1. 2 times 1 is 2, and 2 minus 2 is 0. So it's just kind of working backwards, knowing what I'm going to plug in and knowing what I need to get out. And that will help me identify what I multiply by. So that is the equation. All right, so here's a couple for you to try. Go ahead and try to figure out the equations here. Come on back for the answers. All right. So I can identify that this is cubic. All right, so the center point before it goes down and up normally starts at 0, 0. So I know it's been shifted 1, 2, 3 to the left. So I'm going to start with f of x is equal to, well, moving left, that's inside. So I have x plus 3 and it's cubic. Whoops, close that parenthesis. All right, so let me see if anything else is happening to it. So I'm just going to plug in a couple points. I'm going to plug in negative 3. Negative 3 plus 3 is 0, and 0 cubed is 0. Well, that works because the coordinates are negative 3 comma 0. This point, x is negative 2, y is negative 1. So if I plug in negative 2, I should get 1 out. All right, negative 2 plus 3 is 1. 1 times 1 times 1 is 1, but I need it to be negative. Well, if I multiply it by a negative on the outside, that will work. And if you think back to what it should look like, normally the cubic goes up and down. So you can see it has been flipped. Well, it could be flipped that way, but it could also be flipped this way. And I'm going to say it was flipped over the x-axis, because let me see, I could check both ways. Okay, the other way that it could potentially be would be f of x equals negative x plus 3 cubed. So let's just plug in some points, see what happens. So again, this one where I'm going to check the point when x is negative 2, y should be negative 1. All right, plugging in this. I have negative 2, which makes it positive 2. 2 plus 3 is 5, and 5 cubed is not negative 1. So I know this one does not work. That's how you can identify between the two. You can always try them both, see which one works. Okay, I'm going to double check. Plug in negative 2. Negative 2 plus 3 is 1. 1 cubed, 1 times 1 times 1 is 1, and it makes it negative, so it is negative 1. Yep. I'm going to do one more just to make sure. Plug in negative 1, and I should get out negative 8. Negative 1 plus 3 is 2. 2 cubed, 2 times 2 times 2 is 8, and it's negative. Yes, it does work, so this is my answer. So sometimes it takes a little while. Try a couple of different things. All right, this one. We know that it is absolute value because it's that V shape. It's been moved 4 right and 3 down. So f of x equals, it's not reflected. It doesn't look like it's stretched, but it could potentially be, so we'll always double check. So we have x moving 4 to the right, minus 4. Moving 3 down, minus 3 on the outside. I'm going to plug in that vertex. If I plug in 4 for x, I should get out negative 3 for y, because those are the coordinates. 4 minus 4 is 0. Absolute value of 0 is 0, and 0 minus 3 is negative 3. I always want to check with another point because that's how you can identify if it's multiplied by something, inside or outside. So I'm going to plug in 2, and I should get out negative 2. 2 minus 4. Is that right? Plug in, 3. Numbers are kind of small. Plug in 3 and I get out negative 2. So 3 minus 4 is negative 1. Absolute value of negative 1 is 1. 1 minus 3 is negative 2. So that one did work. So I know this is correct. All right, next. Identify the transformation. All right, so x is multiplied by 2. It's not inside the parentheses, it's outside. So vertical stretch by factor of 2. I'm just going to put by 2. And there's a minus 3 on the outside, so it also shifts it 3 down. All right, absolute value. This one, we can see that there's a 5 in the front, but if you want to get it in the correct order where the value is added or subtracted on the back, you can really see what's happening. So we have g of x equals, well, this minus goes in front of the absolute value of x plus 5, and that 5 is positive. So negative absolute value of x plus 3, and this 5 is positive, so plus 5. So when it's in that correct order, it's a little easier to identify what's positive, what's negative. All right, so we have this minus, it's being multiplied by a negative, so that's reflection over x-axis. And again, it'll just flip it over because it's the V-shaped graph. The plus 3 inside moves our graph 3 left. And the plus 5 on the outside moves our graph 5 up. Okay, so that one was a little easier than creating the actual functions or equations. All right, go ahead and try these two. Come on back for the answers. All right, so we have the square root. So it's times 2 on the inside. So this is the horizontal dilation, and when it's multiplied by a number bigger than 1 on the inside, it's a compression. So horizontal compression by 2. And it's minus 1 underneath, and so that's moving it 1 right. So that starting point would be move 1 to the right. All right, we have a cubic here. Multiplied by the negative inside, remember, that's our reflection over the y-axis. Plus 4 on the outside, so that's moving it 4 up. All right, next thing, we're now going to write some equations if we're given a verbal description of what is happening. Let's see. Okay, a parabola. Well, we know that's quadratic. Facing downwards, so it's been reflected over the x-axis, and its vertex is at 3, negative 1. Well, if this is the x-coordinate, that's the y. The x-coordinate would be what shifts it left and right. Y would be what shifts it up and down. So we can create this. F of x is equal to, all right, remember, facing downwards. That's multiplying it by a negative on the outside. We have x. Remember, moving it left and right is what's inside. And because it's 3 right on the x-axis, that would be minus 3. And it is a quadratic, so squared. And minus 1 shifts our graph 1 down. All right. Next one, a cubic function. So cubed is reflected over the y-axis and has been shifted 4 units to the right. So f of x equals All right, reflection over the y-axis is the multiplied by the negative inside the parenthesis. And 4 units right, remember right and left is inside. Going right is -4, and it is cubic. Okay. All right, so here are 2 for you to try. Go ahead and try them out. Come on back for the answers. All right, a square root function has been vertically stretched by a factor of 3 and begins at 0, -4. So the x value stays where it is. It doesn't move left or right, but y shifts. So we have f of x is equal to vertical stretch by a factor of 3. That's multiplying by 3 on the outside. Square root of x. It doesn't move left or right at all. It's at 0. But it does go down 4, so -4. All right, absolute value function. Horizontally compressed by a factor of 2. That's inside and has a vertex of -3, 2. So f of x equals horizontally compressed, absolute value. And horizontal compression is inside, and we have 2 times x. Right, the x value moves 3 left. So remember that's +3 inside of the absolute value bars, and y moves our graph up 2. Perfect. Okay, last thing. Graph the given function. All right, so we have a vertical stretch of 2, and it moves 1 up. So if that always tells me like I can start at the vertex. My vertex normally be at 0, 0. I can tell it'll be at 0, 1. So this is the vertex. So remember this is a quadratic U-shaped. So it's at 0, 1. And I can just plug in some points. So I found the vertex. I need to figure out a couple of points to the left and right. So I can do 1, 2, -1, and -2. Okay, plug in 1. 1 squared is 1. 1 times 2 is 2. And 2 plus 1 is 3. Plug in 2. 2 squared is 2. 2 squared is 4. 2 times 2 is 4. 4 times 2 is 8. 8 plus 1 is 9. Plug in -1. -1 squared. Remember, you have to do squared before you multiply it by the 2. -1 times -1 is +1. 1 times 2 is 2. 2 plus 1 is 3. Plug in -2. -2 squared is +4. 4 times 2, 8. 8 plus 1 is 9. So when x is 1, y is 3. When x is 2, y is 9. When x is -1, y is 3. And when x is -2, y is 9. If you want to plug in your vertex to make sure you did it correctly, you can. Plug in 0 for x. 0 squared is 0. 0 times 2 is 0. And 0 plus 1 is 1. So we did graph it correctly. And you can see that it does look like a quadratic, a parabola. It's the U shape. And it's just shifted up 1. And little vertically stretched by a factor of 2. All right, here we have a cubic. All right, multiplied by 1/2 inside. Okay, so remember that's horizontal stretch because it's between 0 and 1. And +1 moves our graph. Remember, inside is left and right. So +1 will move it left 1. So that's dealing with x. Y stays where it is, so, whoops, x moves left 1, so -1. Y stays where it should be. So I know that's my starting point. So when x is -1, y is 0. Then I'm just going to create my table, x and y. Do 2 on either side, so let's do 2, 1, -1, oops, 2, 1. sorry, 1, 0, -2, and -3, because we did shift our graph. So we have plug in 1. 1 times a half is a half. Well, that one's kind of ugly. So let's pick a different one. If we pick even numbers to plug in, then we won't have to worry about halves because our denominator is even. So I'm going to go back to the 2, and here I'll go to 4. That's always good to check. So if you have like 1/3, I would pick like 3, 6, and 9. So always look at that. So I'm going to plug in +2. 1/2 times 2 is 1. 1 plus 1 is 2. 2 cubed. 2 times 2 times 2 is 8. Plug in 0. 1/2 times 0 is 0. 0 plus 1 is 1. 1 cubed is 1. Plug in -2. 1/2 times -2 is -1. -1 plus 1 is 0. 0 cubed is 0. Okay, plug in -4. -4 times 1/2 is -2. -2 plus 1 is -1. -1 times -1 is +1 times -1 is -1. So when x is, let's see, 2, y is 8. When x is 0, y is 1. When x is -2, y is 0. And when x is -4, y is -1. Oh, so we can identify that because we had our horizontal stretch of 1/2, we actually had to take that into account before we found the vertex. So I'm going to take this vertex out because that isn't the vertex. If I had multiplied it times, okay, so if I had taken that into account, that -1, and multiplied it times 2, it would have been at -2. All right, so our vertex is actually at x is -2, y is 0. And I can identify, because we know how cubics work, that when this point that is 1, 2, 3, 4 to the right of our vertex is 8 up, so 1, 2, 3, 4 to the left of the vertex should be 8 down. And you can see that it is horizontally stretched out. Again, my error was finding the vertex. I forgot to take that into account because it was inside the parentheses. So always make sure you're checking on that. So if it's multiplied by something inside the parenthesis, you can always just start with the table. All right, so let's have you do a couple. Last 2 problems. All right, go ahead and pause it here. Come on back for the answers. All right, so we have multiplied by a negative, and it's moved to right. So this is the V graph, so I can see that it's moved 2 to the right, and multiplied by a negative. So I can identify, based upon the fact that I know what the parent function looks like, it should look like this, but I'm just going to double check, plug in my values. So I'm going to say that the vertex is when x is 2, but again, it's always good to double check yourself. So I'm going to do 0, 1, 2, 3, and 4. So plug in 0. 0 minus 2 is negative 2. Absolute value of negative 2 is 2. And then the negative outside makes it negative 2 again. Plug in 1. 1 minus 2, negative 1. Absolute value of negative 1 is 1. Make it negative. So it's negative 1. Plug in 2. 2 minus 2 is 0. So absolute value of 0 is 0. Negative is still 0. Plug in 3. 3 minus 2 is 1. Absolute value of 1 is 1. Make it negative 1. Plug in 4. 4 minus 2 is 2. Absolute value of, 4 minus 2 is 2. Absolute value of 2 is 2. Make it negative. Okay, so when x is 0, y is negative 2. When x is 1, y is negative 1. When x is 2, y is 0. When x is 3, y is negative 1. And when x is 4, y is negative 2. So if you hadn't graphed those points, you could graph them now. But I can see that that was correct. I'll make them a little more even. There we go. All right, last one. All right, so we have a square root function. So it's going to be the little curve shape, negative on the inside. Okay, but it is moved 2 down. Okay, so again, I'm going to plug in my values of x and get out y. Okay, I'm doing square root, so I only want to plug in values that'll give me perfect squares, and since x is the only thing under there, and I can't have a negative under there, so the smallest value that I could plug in is 0. Because I can't have negatives, but if I plug in 1, I'll have negative 1 under there. So you always have to think about that. If there's already a negative times a negative, they're going to cancel each other out and create a positive. So I actually do have to plug in negatives, meaning 0 is actually going to be the largest. Okay, so I have my negative 1. Another perfect square would be if this is 4 underneath, so negative 4, so my negatives can cancel each other out, and I'm going to do one more, 9, and it has to be negative. All right, so plug in 0. Square root of 0 is 0, minus 2 gives me negative 2. Plug in negative 1. Negative, negative 1. Negative times negative 1 makes it positive 1. Square root of 1 is 1, and 1 minus 2 is negative 1. Plug in negative 4. Negative times negative 4 is positive 4. Square root of 4 is 2, and 2 minus 2 is 0. Plug in negative 9. Negative times negative 9 is positive 9. Square root of 9 is 3. 3 minus 2 is 1. So go ahead and graph this. When x is 0, y is negative 2. And that's what showed us, remember this is down 2. So we knew right away that it was shifted down 2, and that negative underneath we had to account for. So let's see. That should have been a flip over the y-axis. Normally our graph is just right here, so let's see. When x is negative 1, y is negative 1. When x is negative 4, y is 0. And when x is negative 9, y is 1. So it did, let me graph this, connect the points. It did flip it over the y-axis. All right, hopefully you were able to do all those and work with transformations with functions, with graphs, and with verbal descriptions.